Okay, so the second analysis here is we're looking at a data set dealing with like fear of math and statistics. And so we're going to load it in. Note that we want strings as factors as true. And all that means is that we actually, anything that's a string variable, we're going to treat as a factor. But let's just look at the data first. So we can see things like the gender, what made you are, why you want to take this horrible math or stats class, something that I probably wouldn't be allowed to do, and set different levels of exams for different students. You can have an easy, moderate, difficult, or impossible exam, how caffeinated you are, your kind of phobia of statistics, previous math. And then we have like within the class, you've got a math quiz out of 50 and a stat quiz out of 10. Just ignore that experimental condition. But we also have some measurements of like your heart rate, your general heart rate, your heart rate pre and after the exam, and same for the anxiety. So this person has an anxiety level of 17, which goes up directly before the math stats exam and then drops a little bit after the exam.
So let's just have a look at the STR. And we can see here that gender's a factor, major's a factor, the reason for taking is a factor, and the experimental conditions are factors. They were brought in as strings, and pretty much everything else is in numbers. It's a very simple data set. We can look at like the first 10 items. So these are just basically the first 10 students, head, or we could look at the last 10 items. We'll spend a lot of time on that. Okay, so let's just summarize the data. And you can see the summary just gives you summary statistics for each variable. So we've got, for example, heart rate base has a median value of 72, mean of 72.27, and we also got the minimum and maximum values and the two quartiles, i.e. the 25th and 75th percentiles. Okay, so we can also do a little bit extra in that, other ways of calculating means. So this is kind of how you would do it in base R when we did it in the tidyverse above. As I think I said before, in R, you could do like, there's about 20 ways of doing each thing. So there's a function called colmeans, and we basically, columns 12 to 18 are just the continuous columns. So if we have a look here, we'll see this is all numeric data. So we're just going to get the colmeans of that. And there we go. We get the mean of each of these different variables. And another way of doing this is a function called apply. And apply allows you to apply a function, in this case mean. And the two basically means that we are summarizing columns. If we were doing one, then we'd be summarizing rows. So it's exactly the same thing. Okay, so let's just say to make things a little bit easier to interpret, we're going to make the math quiz out of 100. So it's in a percentage scale. We're also going to change, we won't, but just we're also going to change, we're going to have a heart rate pre to post, just showing the change in heart rate. So this is just, we're creating new variables. The dollar means, it goes data frame, dollar, variable name, and we can create new variables by assigning from existing variables. So let's just check IHNO and Math Quiz 100. And you can see that we have all these variables. We also have a few NAs, which basically means we got missing data. And we can actually summarize our variables. So let's just do as.dataframe IHNO Math Quiz 100, and then do a summary. And there we get the summary from the Math Quiz 100. And it actually says, okay, we've got 15 NAs here. This is exactly the same. Gives us the same information. Now, if we didn't do drop equals false, let's just play around with that. We would actually take it as a vector and we'd summarize it if it was a vector. So if we did like, just so to remind you what the drop does, because that caused a bit of confusion in the first practical. This is asking us to get the Math Quiz 100, and you can see we just get a vector of numbers. But if we put drop equals false, it keeps it in the data frame format. So we have a data frame with just one column. Okay, so there's a function called is.na, and this returns whether or not we've got missing data. So for each item with Math Quiz 100, the true means that we have an NA. It's missing data. And one thing we can do now is we're going to do the Math Quiz 100 and we're going to remove missing data. So let's just have a look at this. Yeah, forgot the right bracket. This is just creating logical. This is another way of accessing data frames in R. You just send it true or falses for every single item, and you actually, it will return the trues and it would not return the falses. So, you know, when we did the indexing in week 1, we'd have to say, okay, I want 1, 2, 3, 4, 5, 6, 7, 8, 9, not 10, 11, 12, 13, etc. That would be complicated. But if we just pass it true or falses, it returns the values for which there's truth. So now if we look at, we're going to create this value called plot val. You see it's got rid of all of those NAs. All of those NAs are now missing. And we want the equivalent major information. And again, we only want the major for items that have a Math Quiz 100 result. So let's just see what we got. And there we go. We have the majors, and we'd have the same number of majors as the plot vals. Now let's just do something very simple in R. Let's just do a histogram. This is using the R-based graphics. Looks pretty, oh, sorry, where did that go? Plots. Looks pretty nice. You can see it's basically just like you probably did in middle school or something when you draw the histogram. It splits it up into kind of tens. So we have the Math Quiz in terms of tens. And you can see that the most common, the kind of the modal category is between 50 and 60. A few people have got less than 20. And a few people have got between 90 and 100. So this professor isn't messing around. This professor sets hard exams. So we can actually send some, just as a reminder, if you want to find a little bit about each function, just put the question mark there. And so for histogram, it tells you what it is, and it tells you all the different things that you could pass to the function. So you could pass the main, which gives it a title. You could pass the label for the x-axis. There's lots of different things you can pass in the number of breaks or a vector telling you where the breaks are for the histogram. But we're going to stay simple. We're just going to pass the main. We're going to have a main title. We're going to have a title for the x-axis, and we're going to have 10 breaks, and we're going to make it dark blue but with black borders. And the prob equals false means we're just doing a count rather than a proportion. So here we are. Here's our new slightly fancier histogram. It's in blue with black boundaries. We see it's got a title and it's also got an x-axis. Okay, now we can also convert to probability densities. And what we're doing here is we're just putting prob equals true, exactly the same as before. Oh, I've got the weird spacing in that file. So let's just run histogram. And you see now, rather than numbers, we get the actual proportion between 0 and 1. So let's do something fancy. Let's do the mean, calculate the mean, calculate the standard deviation using the SD function. So we have, that's the mean exam score, 58. Said professor's not messing around. Standard deviation, 18.9. And we're going to draw a normal curve. The denorm function basically means that we're going to, for the mean and the standard deviation, for each x value, we're going to give what would be expected by the normal distribution. We'll talk a little bit more about that in these sort of functions in week 3. We're going to make it red so it contrasts with the blue. LWD is just the width of the line. We're not going to do anything with the y-axis. And we're going to add it to the existing graph. We're just not going to draw it from scratch. And there we can see how similar our histogram is to normal. Okay, so we're going to go back to ggplot2. And we're going to do some histograms with ggplot2. ggplot2, as we did in the previous, ggplot as we did in the previous exercise, you pass the data set. AES determines the values you're using. So here we're going to do x equals Math Quiz 100. And we're going to fill by major, and we're going to use GM histogram with a bandwidth of 5, and we're going to do scale fill brewer, and we're going to use a set. This is all this basically does is this sets the color scheme, and it has lots of different kind of palettes. So we've got like this. I'll show you in a second. So here we've got a histogram, and we're actually doing by a major. This is really just a bit too complicated. It doesn't really work very well with multiple categories. But say we did gender, this would be a little bit better, and we could kind of, contrast where the males are with the females. Still not brilliant. Let's actually have a look at scale fill brewer. So I'm just going to do question mark. And let's go down a little bit. And it gives you the palettes you can do. Let's choose dark too. And let's just see if this makes any changes. Yeah, that's actually a slightly nicer palette. But let's not change this. Okay, and there's a couple of variants to this. We can, with the histogram, we could send position equals fill. And that does basically everything relative. So we get the proportion of, so this, the interpretation of this would be the, say, the proportion of people with a score in this bin around 50 would be about 25% biology, a little bit less pre-med, then about 20% psychology and sociology. But we can see of the top scoring students, there might not be many of these. These are all psychology students. And then the next one, the same, but we're going to choose position equals dodge. And this time they're all next to each other. I don't like that graph. Again, there's probably too much information on it. So let's do something a little bit fancy. Let's do, first, let's have 10 breaks. So we're going to actually set these breaks manually. And what we're going to do, we're going to actually do a little population pyramid. So we're going to get all the male values. So if we look here, it's like we did before with the logical, and we're going to say is dot not NA, but we're also going to see if the people are actually male. So this is basically returning anybody who has 100 on the, sorry, anybody who has a score on the math quiz and is male. So here we have gender male. And what we're going to do is that the function cut basically takes the breaks from 0 to 100 and assigns each data set to one of these kind of breaks. So let's just see what we got. So each of the items, it no longer is a number, it's the kind of the boundary that they're within. So that whether they're between 50 or 60, 60 or 70, etc. And we're now just going to put this into a table and we're going to count it. And we get the counts for each of the kind of the ranges of exam scores. Now notice I've made these negative. And that's not anything mathematical. It's purely because I'm going to do a graph with male and female and I want the males on one side, so I multiply everything by -1. I do exactly the same thing for the females, but I don't multiply it by -1. And we get the females. And you can see the kind of the frequencies here. So 10 females got between 50 and 60. And now we're going to combine the data frame. So we're just going to put the male frequencies and the female frequencies. And we're only choosing columns 1, 2, and 4 because we only want the, we basically only want the kind of the bin kind of names once. So let's just show what we get here. So let's do fret combine. And you see, we only want the bins once. If we'd done 1, 2, 3, and 4, we'd get bin male, bin female. And then the names, this just does the name. You could also use col names. That would do exactly the same thing. So we have basically the bins, we have the males, we have the females. Now, if that wasn't complicated enough, for use in ggplot, we want male or female to be an actual column. So what reshape does is, let's just do question mark reshape 2. Sorry, we do melt, the function melt in reshape, sorry. What it does is the function we're going to use, it turns a Y data set. So here we've got a column for males and females into a data set where we have a column of values and another column that says male or female. We're going to do plus melt. We don't want to change anything to do with the bin, so we kind of fix bin by setting it as the ID. And then we're going to reset the names of the columns. And you see here, we have all the males and all the females, but we have a column for gender and a column for frequency. Okay, so now we're going to do a ggplot. We've got X is the bin, Y is the frequency, and we're going to fill by gender. And we're going to do a bar graph, 2 different bar graphs. The first is for females, and we use a function called subset that basically this is just another way of like accessing in the data frame. So I could actually do subset. Let's just, because I've not introduced the subset command before. Subset, you see gender equals female. You see another way of doing this would be fret combine, and we went all the rows where gender is female. So this is the notation we used in week 1, but subset will do the same thing. And you see it gives exactly the same result. So we have G on bar, and this is just the way of doing the histogram. If we do G on bar with stat equals identity, it means we're not doing any statistics. We can get the bars for the histogram. And we set the Y scale, we scale Y continuous, and we need to be negative and positive. So the category with the most males in has 14, which is, we made that negative, so it's minus 14. The category with most females is 10, I guess. And we're going from minus 14 through to 10. And we also have to have then labels, so we have 14 to 0 and 2 to 10. So we want to kind of keep the labels positive. So let me just show you what labels we get. So let's just do that. And this just sets all the labels. And then again, we're using scale fill brewer to get the colors we want, and we're going to give it a title. So let's just see what this beautiful graph is. Okay, so there's our really fancy graph. We've got the frequencies on the X, we've got the actual bins here, and then we've got the males because we multiplied it by -1. So it's a little sleight of the hand. Is we have negative, but we've given a positive frequency count. And then we have the females here. So this is way more complicated than you're ever going to need for anything in this class, but it was just a way to show you how you build up graphs over time. Okay, so the next little thing we're going to do is we're going to do box plots. So we're going to do a box plot of, we'll just do a simple one. We're going to do Math Quiz 100 by the function box plot by the reason that somebody took the class. And we're going to pass in the data, we're going to give it a title, we're going to give the X label and Y label, and we're going to define the color. And here we go. So we see advisor recommendation, personal interest, and program requirement. And you can see that the more people did it for the people who chose a class for personal interest tended to have a higher score than the people who were forced to do it by their advisor or because their program required. Because these are the people who are interested in math and stats. They didn't need to take the course. Now we can make this more complicated with ggplot. We're going to give X is the reason, Y is the Math Quiz 100. We're going to fill by gender, and we're going to use G on box plot, and we're going to use scale fill manual, which is this basically just setting we're going to make things blue or red for males and females. So here we go. We have the females and the males. Just kind of a little reminder of what box plots are. Is the bottom of the box is the 25th percentile, the middle is the 50th percentile, the top is the 75th percentile, which doesn't have to equal 75. That's just what happened here. And here we have sometimes you'll draw a line across, like, let's just go back to the original R1. Like, this is why it's called a box and whisper plot. Um, and that's kind of like the highest value and the lowest value. Sometimes we'll plot outliers, and how we'll plot outliers is we'll take the how high this box is, which is called the interquartile range, the 75th percentile minus the 25th. And going from the top to the bottom of the box, we match out at 1.5 interquartile ranges. And if a point is outside of that, then it's drawn. We don't extend the whisker. We draw the point outside, and we call that point an outlier. Okay, so the last little plots we're going to do is just a simple scatter plot. So here we're going to use the basic R plot function, and we're going to have heart rate pre and heart rate post. And we're going to do PCH. This just tells you what the shape is. So I could do a little question mark and PCH. And this would just actually tell you, here we go. So number 4 is a cross. We could make it a little circle, say if we put 20. And we've got the heart rate pre and the heart rate post. So let's plot things. And here we are. We have all the crosses here. So say if I made this 20. There we are. That actually looks a bit nicer. And now we're going to do, what we're going to do is we're going to add a line. And we're going to use the function AB line that adds a line. And then we're going to add a regression model. Don't worry about this. You're not going to do it until after the middle of the course. But it's just we can add a line to it that looks like a regression model. And there we go. So we have a regression line for that. And the last little thing we're going to do is we're just going to use, there's a function called pairs. And basically we're going to take the heart rate and anxiety measures. All we're doing here is we're doing all rows and then selecting all the columns with heart rate or anxiety. And you can see here, like, there's a positive relationship between the different types of heart rate and between the different types of anxiety. This is kind of clustered into 2 groups. But between some measure of heart rate and anxiety, there isn't really a strong relationship. So these are actually very separate measures. You could have somebody with a high heart rate and low anxiety, and vice versa. It doesn't necessarily mean that somebody with high heart rate has high anxiety. And then we could look at the correlations of the math quiz, and there really isn't much. You see, these are just blobs and messes. We'll talk a little bit more about these sort of patterns when we do regression. Okay, so this was a little bit more advanced than the first video. This is almost like a little bit optional. Just gives you some more technique, shows you how to create some more graphs. And there is an exercise associated with this if you get far enough on the practical. Okay, and that's it for this video.